In this video, we're going to learn how to draw branch chain hydrocarbons. So the first thing I want to mention is that these guys are typically what we would call isomers. So an isomer is when you have the same formula, but a different structure, which causes different properties. So an example of an isomer is C4H10. It could be this one, or it can be this one. Both structures are valid. They have different properties. For example, one is symmetrical and therefore nonpolar, and the other is asymmetrical and therefore polar. And so just by changing the shape of the molecule, you're going to change the properties of the molecule. That's where the term isomer comes from. Don't confuse it with isotope, and don't confuse it with allotrope. So they are different. They sound similar, but they are not the same. Allotrope is actually very similar because it's when you have an element with the same formula, but a different structure and therefore different properties, whereas an isomer is when you have a compound that has different structures and different properties. So that's that part. What we're going to do is learn how to name this giant looking thing. Okay, so let's start. Here's the rules for naming. They're right here at the bottom. It says, first, find and name the longest continuous chain. If there's a double bond or triple bond, it must be included. So here's what that means. So I'm going to highlight that here. So the longest continuous chain, so there's this guy. So now, here's my question. Once I get to this point, I have a choice. Do I go up two more, and then the longest chain would be 1, 2, 3, 4, 5, 6 carbons long, or do I go to the left, and then I can go further? Can I get longer than 6 in a row if I go left? And the answer is, I could definitely get longer than 6 in a row if I go left, because now I've gone 1, 2, 3, 4, 5, and I could go 6, 7, that's 7 in a row, or I could keep going 6, 7, 8. Well, I'm definitely going to keep going. And now the last question is, do I go down or do I keep going? And so I keep going, and then is that the longest continuous chain? And the answer is no, it's not. The longest continuous chain would mean there. So the way you figure it out is you've got to find the longest linkage of carbons in a row in the molecule, and you can't double back. So you can make a turn, okay, but you can't go backwards. You can't go back on a carbon you've already counted. So in other words, I could have went 1, 2, 3, 4, 5, 6. I could go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, or 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's the longest possible chain in the molecule without doubling back. Okay, so that's step one. And then we can actually name that. So I'm going to put the name here. If it were a 9 in a row is a non, and then because it has a double bond, it's a non-ene. Okay, now step 2, it says number the chain to have the lowest possible side group numbers. The double triple bond gets priority. So what that means is, since this double bond is closest to the left, I'm going to start numbering, on the right. I'm going to start numbering on the right. So I'm going to call this carbon 1, carbon 2, carbon 3, 4, 5, 6, 7, 8. 9. The fact that this is bent up means nothing. It could very easily be straight, and then this, which is this blank one, which is a hydrogen, would be in its place, and you could have drawn it straight. The only reason they put a bend in it was to see if you could identify the longest chain and make it a little bit harder for you to do that. So since the double bond is on carbon 2, we're going to call it 2 non-ene. Next part, so step 3. Name each side group before the main chain. So we've got some side groups. Or they're also called branches, but same idea. So think of this as like a tree, and these are the branches. There's a branch of 2, there's a branch of 2, and there's a branch of 1. So for a branch of 2, notice the branch gets a YL ending. So what that means is, normally, we would write this out as 2 carbons in a row would be F. Because it's a branch, it ends in YL. So this would be 4, ethyl, and then this would be 5 ethyl, and then this would be 7 methyl. The reason these are called ethyls is because the branch is 2 carbons in length. It's called 4-ethyl because it's on carbon 4. Whether it be up or down does not make a difference. In real life, they're free to rotate around the molecule in 3 dimensions, so it doesn't matter. Same thing with carbon 5. It's 5-ethyl because it's too long. And again, you could draw it up or down. It wouldn't make a difference because, again, free to rotate. And then this is 7-methyl. Now, what you would do is you would normally put those all together, but that name wouldn't be 100% right either. So I'm going to show you where the mistake is. Normally, you would write it out like this. You would write 7-methyl, 4-ethyl, 5-ethyl, 2-nonene. But there's a couple things. There's a couple reasons this is wrong. One, technically, the branches are supposed to be in alphabetical order, so the ethyls should come first and then the methyl goes second, so that's one thing. But two, we can condense these two down to this. 4, 5 diethyl. Now the reason it gets the di is because if the same group shows up more than once, we can condense them down. Now, again, I know some people might be thinking, why bother to give it an extra name? The fact that there's 2 numbers means that you shouldn't need to tell me that there's 2 ethyls. The 2 numbers tells me that there's 2 ethyls. While I agree with you, that's just not how it's done. And so then that would be this part. And then the next part would be 7-methyl 2-nonene. And that's the full name. All right. So that's how you name hydrocarbons. This one was a harder one. I wanted to start with a hard one. The next thing we're going to do is we're going to condense it. So the way I'm going to condense it to make things easy is I'm just going to condense it from left to right the way we read. I just find that much easier to do. So I'm essentially condensing it backwards. So carbon 9 has 3 hydrogen. Carbon 8 has 2 hydrogen. Now watch how I do this. Carbon 7 has 1 hydrogen directly, meaning this is a hydrogen, right? They don't write, at this point we're not writing the H's in. So there's your 1 hydrogen. But then it has a CH3 on it connected to the other side, so parentheses CH3. The parentheses tell me it's connected to the atom or the carbon behind it. Carbon 6, CH2. Carbon 5 is CH, and then parentheses. Now I condense this one. This first carbon in the chain is a CH2. The second carbon in the chain is a CH3. Now I'm back to carbon 4, C with an H, and then parentheses, CH2, CH3. Then carbon 3 is just a C with one H, carbon 2, a C with one H, and carbon 1, CH3. Now, some people usually ask this question. They say, well, how do I know that there's a double bond there? And the answer is, if you were to uncondense this, you would realize that there would be 1 bond. These 2 carbons, carbons 2 and 3, would be 1 bond short. They would be 1 hydrogen short of being stable. And so the only thing you can do as a result is bond them together to make a double bond. So you have to be able to figure that out when you look at that. You say, oh, it's missing carbons or missing hydrogen, so I'm going to have to double or triple the bonding in order to make it stable. So that is how branch chain hydrocarbons work. Let's do one more practice problem. Let me find it. So now we're going to do this one. And that's it for branch chain. We're going to do a bunch of practice. So again, first step, find the longest chain. It's got to have the triple bond in it. So you could go 1, 2, 3, 4, or you could go 1, 2, 3, 4. It actually wouldn't matter. So it wouldn't matter if I went this way and to the left, or if I went straight across to the left. The reason being, if I number this 1, 2, 3, then on carbon 3 there's a branch 2, and if I did it the other way, it would be 1, 2, 3, and then there'd be a branch of 2 on carbon 3, so it doesn't matter. The name's going to be the same either way. And now here I'm going to go to this carbon, and now the question is, do I go up 1, 2, do I go down 1, or do I keep going across? Well, turns out if I keep going, I can get more carbons in. Now the question when I get to here, do I go up and end it, do I go down and end it, or do I keep going straight across? And straight across is the longest one. Since the triple bond is closer to the right, 1, 2, 3, 4, because if I numbered it the other way, it would be 1, 2, 3, 4, 5. Yeah, so by doing it this way, the triple bond is between carbons 4 and 5. If I did it the other way, it would be between carbons 5 and 6. So there's my 9 carbons. That makes it a non-ine, and specifically 4 non-ine. Now some people ask, why 4 not 5? We always use the lower number. So since it's between carbons 4 and 5, we just call it 4. If it was between carbons 3 and 4, then it would be called 3. All right, now we do our branches. Well, turns out branch of 2, branch of 2. I'm going to use a different color. Branch of 1, branch of 1, branch of 1. So let's combine these branches. So this would be 6 methyl, 7 methyl, 7 methyl. Notice, this does not count as a branch of 2 because I have 1 down and 1 up. That's 2 individual branches of 1. So that's why I have 7 methyl written twice. That'll show up in the name. This one would be 6 ethyl, and this one would be 3 ethyl. So now let's combine it. The methyls, let's do the ethyls first because alphabetically E becomes before M. So the ethyls are going to be 3, 6 dash diethyl. Notice I'm using dashes to separate letters and numbers, commas to separate numbers from other numbers. And then for the methyls, it's going to be 6, 7, 7 dash trimethyl, and then I overshot a little, and then it would be 4 non-ine. So notice a couple things. There were 2 methyls on the 7, so the number 7 has to be written twice. If they happen to be on the same carbon, you still have to double that number up, because what it's saying is what this really means is trimethyl means there's 3 branches of 1. 6, 7, and 7 are where to find them. Diethyl means there are 2 branches of 2. 3 and 6 are where to find them. 4 non-ine says there's 9 carbons in a row. There's a triple bond between carbons 4 and 5. The 4 is where to find it. So that's what it means. And then the condensed structural is going to look like this. We're going to start with carbon 9, CH3, CH2. I just write a C because carbon 7 doesn't have any H's of its own. It only has branches. So I just write a C. Then I do a parentheses, CH3, close it, 2. So you can get away with this because the branches are the exact same, so you can put a 2 out. If you aren't comfortable doing that, then you could just write parentheses CH3, close the parentheses, a new parentheses, another CH3, close the parentheses. You'd have to write it twice. When you see carbon 6, hopefully it makes more sense. So there's carbon 6. There are no H's for carbon 6 either, so it doesn't matter which one I do first, I don't care. So parentheses, let's do the bottom one first. CH3, close it. That's for this one. Then I do another set of parentheses. CH2, CH3, that's this one. Again, close it. Now I'm on to carbon 5. Carbon 5 has no H's, so I just write a C. Carbon 4, no H's, so I just write another C. Carbon 3 has 1 H, and then in parentheses, CH2, CH3, that's this group, and then CH2, CH3 for carbons 2 and 1. So that's how you name hydrocarbons. These are very complicated hydrocarbons. Normally, the ones you're going to be doing in lab are not going to be this large that often. They're going to be much smaller and take a lot less time. But if you can understand this one, then the smaller ones should be no big deal because they should be pretty easy at this point.